Today we are going to discuss about the antiamoebic drugs. In last week we have discussed about, in last lecture we have discussed about the anti-leprotic drugs. Now we are moving further for the study of antiamoebic drugs. So learning outcomes of this lecture is after completion of this lecture, you will be able to define the anti-amoebic drugs. You will be able to classify anti-amoebic drugs, and you will be able to draw the chemical structure of metronidazole. So in these chapters, we are going to study the structure of only one drug, that is metronidazole. And once you have got the books, then you have to prepare one chart, that is properties, uses, and storage condition of other drugs of antiamoebic agents. So today we are discussing the 3 points, that is definition of antiamoebic drugs, classification of antiamoebic drugs, and we are going to discuss how to draw, how to remember the chemical structure of metronidazole. So before going to start the anti-amoebic drugs, you must know the amoebiasis. That is, it is also called as amoebic dysentery. If you visualize or observe this image, which I have taken it for you people for better understanding, isn't it? So here is the large intestine and small intestine, and here is the infections of some of the parasites. So infection of parasitic present in an intestine due to of amoeba, and the biological source or biological name of amoeba is Entamoeba histolytica. So a parasitic infection to the colon or intestine with the amoeba, that is Entamoeba histolytica, that condition is called as amoebiasis, or it is also called as amoebic dysentery, because when there is infections of amoeba, when there is infections of amoeba, there is frequent discharge of the fecal matter, that is diarrhea and dysentery is occur. That's why the dysentery produced by the infections of amoeba is called as amoebic dysentery. So this is a microscopic parasites. Microscopic means what? We cannot able to observe through our naked eyes. No doubt it is a parasites. Parasites means what? They are depends on the host for their energy and food. ते त्यांच्या एनर्जीसाठी आणि फूडसाठी ते होस्टवर डिपेंड असतात. होस्टवर म्हणजे दुसऱ्यावर अवलंबून असतात. ते आपल्या शरीरात आले की आपल्या शरीरातील अन्न, आपल्या शरीरातील एनर्जी ते वापरतात आणि त्याच्यावरून त्यांचं ते जीवन चालू असतं. म्हणून त्यांना आपण पॅरासाइट्स म्हणतो. डिपेंड्स ऑन अदर्स. सो इट इज मायक्रोस्कोपिक, मीन्स वी कॅनॉट एबल टू visualize through the naked eyes. That's why it is called as microscopic parasites. Some other parasites are macroscopic, means we can able to see through our naked eyes. For example, worms आपण डोळ्याने पाहू शकतो, जंत म्हणतो आपण त्याला, हो की नाही? तर ते झाले मॅक्रोस्कोपिक. आणि अमिबा काय आहे मग? मायक्रोस्कोपिक. So it is a microscopic parasites enters into the body through contaminated foods and water. Remember, this type of dysentery or amoebic dysentery is because of taking or administration of or ingestion of the contaminated food or waters. So if the food materials or water what we are going to drink is contaminated with the amoeba, that is Entamoeba histolytica, then this amoebic dysentery may occur. Okay. So in that condition, the infection is common in the poor sanitization or living conditions. Wherever there is no proper hygiene condition is maintained, there is not proper sanitization of discharge material is not taken place. In that area, the infection is very common. In that area, infection is very common because on that particular area, the hygienic condition is not maintained. On that particular area, hygienic condition is not properly maintained. Most of the times, this amoeba affects the intestine. This amoeba affects the intestine and due to which it causes the amoebic dysentery. Sometimes, apart from intestine, this amoeba can cause or can invade the other organs such as liver, lungs, and kidney. That time, that infection is called as extra-intestinal infection. That time, that infection is called as extra-intestinal. Means apart from intestines or other than intestine, this amoeba, Rintamoeba histolytica, is able to invade the other organs. They have infected the other organs such as liver, lungs, and kidney. That condition is also called as the extra-intestinal infections or extra-intestinal amoebiasis. Okay. So it mainly affect the intestine. That's why I have taken the image of intestine. So you will be able to remember where these amoeba can infect within our body. Symptoms of amoebiasis is there is abdomen pain. It affects on gastrointestinal tract such as blood in stools, diarrhea, and feculence. Or someone pronounce it as flatulence. Okay. Feculence means what? There is formation of gas in GIT. There is formation of gas in GIT. It also affects whole body due to a frequent discharge of the fecal matter due to loss of water in diarrhea. That particular persons may experience the fatigue. Sometimes the fever may be there, and due to the intestinal infections, there is loss of appetite. And because of loss of appetite and loss of the electrolytes or loss of water, there is loss of weight also. So these are the common symptoms which are observed during the amoebiasis. So for the treatment of this amoebiasis, we are using the agents. That agent is called as anti-amoebic drugs or anti-amoebic agent. So it may be named as amoebicidal drugs also. Remember, anti-amoebic agents or amoebicidal drugs are the same. How? If you observe the suffix for this word is cidal. So it comes from cide, C-I-D-E. Bactericide means the agents which are having ability to kill the bacteria. Cide means the killing. Cides means killing. So amoebicide means what? The agent which kills the amoeba, which inhibit the further spreading of amoeba by killing the amoeba. That agents are called as amoebicides, or it is also called as anti-amoebic. Anti means to oppose. Anti means to oppose. Okay. So anti oppose to what? Amoeba. So those agents which oppose the amoeba, those agents which are useful to expel out the amoeba from the body by killing the amoeba are called as anti-amoebic agents, or it is also called as amoebicidal drugs. So anti-amoebic agents are also called as amoebicidal drugs. So the agents which are used in the treatment of amoebiasis because of its having capacity to kill the amoeba. So that's why that agents are useful in the treatment of amoebiasis. Amoebiasis means what? The infections are due to of amoeba, and biological name of amoeba is Entamoeba histolytica. It is defined as the chemical agents or drugs which are capable to kill the amoeba species are called as anti-amoebic drugs or amoebicidal drugs. Any chemical agents which having capacity to kill the amoeba or any other amoeba species are called as anti-amoebic agents. It is also called as amoebicidal drugs or amoebicides. लक्षात घ्या, वेगवेगळे नावं आपल्याला माहिती पाहिजे. एक्झाममध्ये किंवा व्हायवामध्ये असं प्रश्न विचारू शकतात. मग आपल्याला असं वाटेल की सरांनी शिकवताना आपल्याला अँटी अमेबिक एजंट शिकवलं, अमेबिसायडल एजंट्स किंवा अमेबिसाइड्स असं काही शिकवलं नाही, तर मग मात्र आपल्याला थोडा कन्फ्युजन होतं, प्रॉब्लेम होतो. म्हणून आपल्याला त्याचे जे काही वेगवेगळे नावं आहेत ते आपल्या सर्वांना माहिती असणं खूप गरजेचं आहे. हो की नाही? And agents which are used in the treatment of amoebiasis and which having the capacity to kill the amoeba are called as anti-amoebic agents or amoebicidal agents or amoebicides. Let's see the next part of our today's lecture is the classification. Chemically, it is classified into the different classes. First is the natural alkaloids. For example, imethine. Second class is the amides. First class is alkaloid. Second class is amides. For example, dicloxamide furoate, teclosan, and etofamide. So these are the examples of amides. Amides means what? These drugs having the functional group. Which functional group? Amide functional group in their structure. But as per the syllabus of second year diploma pharmacy, you need not to study the structure of these drugs, but according to their structure, they are classified amides. Next class is antibiotics. For example, tetracyclines and paramomycins. Next class is nitroimidazoles. Nitroimidazoles. For example, metronidazoles and tinidazoles. So I have written metronidazole in other color as well as I have marked it as asterisk or star. It means that you need to study the structure of metronidazole. Another example is tinidazole. Most of the times, if you visit the medical shops or physicians when you are suffering from the diarrhea and dysentery, that time most of the physicians they have give the prescriptions of these tablets. Normate. So it is the combination of NOR stands for norfloxacin, which is synthetic antibacterial drug. Norfloxacin. And MET stands for metronidazole. So they have given in combination for the treatment of the diarrhea or dysentery. You can see nowadays this Normate is not used. Now it's using the O2. O2 means 2 oxygen. Ofloxacin and ornidazole. First O stands for ofloxacin, which is synthetic antibacterials or quinoline antibacterials, and second O is ornidazoles. So ornidazoles is the from the class azoles. So metronidazole is basically useful for the treatment of diarrhea and dysentery. Another class is the halogenated hydroxyquinolines. For example, idoquinol. Halogenated hydroxyquinolines. So quinoline वर hydroxy group आहे आणि halogenized. त्याचं एक्झाम्पल आहे आयडोक्विनॉल. So there are 5 class. How many class are there? 5 class. It's very easy to remember. You can just make some shortcuts. A3NH. NH stands for National Highway, and you can um, give any logic for this A3. So first A is for alkaloids, second A is for amides, third A is for antibiotics, N for nitroimidazoles, and H for halogenated hydroxyquinolines. Okay, so you can remember the classification by applying some shortcuts. So these tricks are very useful to remember the n number of classifications within very short time. So this is one of the smart way to remember the classifications. So in this antiamoebic agents, we need to study the structure of metronidazole. I have not written the heterocyclic ring in brackets. Why? Because here the class itself indicates that the which heterocyclic ring present in metronidazole. That's why I have not written the name of heterocyclic ring present in the structure of metronidazole. Okay, because its class name itself indicates its heterocyclic ring. नाहीतर तुम्ही म्हणाल की सरांनी आपल्याला सांगितलं क्लासिफिकेशन लिहिताना ज्या ड्रगचं आपल्याला स्ट्रक्चर अभ्यासायचं आहे त्या ड्रगची हेट्रोसायक्लिक रिंग किंवा त्या ड्रगचं मेजर फंक्शनल ग्रुप्स आपण ब्रॅकेटमध्ये लिहितो कारण आपल्याला ते लक्षात राहायला सोपं जातं आणि स्ट्रक्चर त्याच्यामुळे आपण इझिली त्याच्यापासून तयार करून आपण इझिली ते काढू शकतो. ही आपली पद्धत आहे स्ट्रक्चर लक्षात ठेवण्याची. पण ह्या क्लासिफिकेशन मध्ये मी मुद्दामहून कंसामध्ये ब्रॅकेटमध्ये कुठेही हेट्रोसायक्लिक रिंग लिहिलेली नाही, कारण त्याचं कारणच असं आहे की तुम्ही जर क्लासिफिकेशन व्यवस्थित जर बघितलं तर 4 नंबरचा क्लास आहे नायट्रोइमिडाझोल्स आणि त्याचं एक्झाम्पल आहे मेट्रोनिडाझोल्स. म्हणजे याच्यामध्ये कुठली रिंग असली पाहिजे? इमिडाझोल्स रिंग असली पाहिजे, त्याच्यावर नायट्रो ग्रुप आहे. ओके, दॅट्स वाय वी हॅव नॉट मेन्शन the heterocyclic ring present in the structure of metronidazole in a bracket. Sorry, here is a one question for you. You can reply it in chat box. Name the heterocyclic ring. So just try to give the correct name in chat box. The ring is in front of you. Okay, very good, very good, very good. Now I will show you the correct answer. The correct answer is on your screen now. 1H imidazole, not only imidazole. It's 1H imidazole. It is what? 1H imidazole. So don't forget to add the 1H because at 1 number position there is extra hydrogen. As we have seen the heterocyclic nomenclature rules, in that we have seen what to do with the extra hydrogen. Okay. So metronidazole is an imidazole derivative and it is an example of nitroimidazole derivative. So this is the structure of nitroimidazole derivative. So always remember you have to add a nitro group on last number of carbon atom, that is on 5th number carbon atom. So this is the imidazole ring and here at number 5 you have to add the nitro group, so it will become nitroimidazole. So it's very easy to remember the structure of nitroimidazole. First you have to go step by step. Okay, how? First you have to draw the structure of imidazole. So imidazole is nothing but its end with the OLE. So OLE is the suffix for the 5-member heterocyclic ring containing fully unsaturation. So 5-member ring containing 2 double bonds. Okay. So AZ means nitrogen. So you have to add the 2 nitrogen, one at 1 number position, another at 3 number position. So 1 and 3 nitrogen is you added. So it becomes imidazole. So once you have draw the structure of imidazole, then try to draw the structure of nitroimidazole. So nitro group you have to add at last number of carbon atom. So here you have to start the numbering from this nitrogen atom, because as per the IUPAC nomenclature rules, you have to give preference to the heteroatom which is a saturated. लक्षात घ्या, सॅच्युरेटेडला आपल्याला प्रेफरन्स आधी द्यायचा आहे, म्हणून आपण त्याला प्रेफरन्स दिला. Why? Because saturated is more preferred than unsaturated atom as per the heterocyclic nomenclature rules. You can give the numbering like that also, 1, 2, 3. So that system also gives the same number to the nitrogen atom. But as per the rules, you have to start, or you have to give the lowest possible number to the saturated atom. So this is the saturated atom. So that's why we have given started number 1 here, 2 here, so 3. We cannot do the clockwise directions because it will give the 4 number to the another nitrogen atom. So you have to give a numbering in a such a way that both heteroatoms possessing the lowest possible number. So you have to add the nitro group at 5 number positions. So it becomes 5 nitro 1H imidazole. 5 nitro 1H imidazole. Okay. So first step is over, to draw the basic heterocyclic ring, and this is the 5 nitro 1H imidazole structure, and this is the structure of metronidazole. Now you need to observe the both structure. You need to observe the both structure. That is 5 nitroimidazole structure or nitroimidazole structure and metronidazole structure, and try to point out the difference. Okay, try to point out the difference. I have already given the number and I am waiting for your answer. What are the different groups, or what is the difference between these two structures? जे तुमच्या स्क्रीनवर जे स्ट्रक्चर दिसत आहे याच्यामध्ये काय फरक तुम्हाला जाणवतो, तो फरक तुम्ही मला जर लिहून पाठवला चॅट बॉक्समध्ये तर तुम्हाला हे स्ट्रक्चर लक्षात राहायला सोपं जाईल. कारण आपली एक पद्धत आहे की आपण स्ट्रक्चर काय करतोय, ऑब्झर्व करून लक्षात ठेवण्याचा प्रयत्न करतो. तर हे झालं तुमचं बेसिक. Nitroimidazole is an example of what? Nitroimidazole. Sorry, metronidazole is an example of nitroimidazole. So this is the nitroimidazole structure. This is the structure of metronidazole. Try to point out the difference between these two drugs, two structures. At 3 position, methyl group is attached. 3 position वर दिसतोय का methyl group पूजा बडगुजर? At second position, ethyl group. Second position वर ethyl आहे का? Second number attached the methyl group. First number is ethanol. Very good. Uday Patil, ethanol and methyl group attached to the 1 and 2 number. Very good, Uday. Very nice. Pen beach. Yes, correct. So you have to be very particular while observing the structures of basic heterocycles and structure of drug, and try to point out the difference. If you are able to pointing out the difference, then it will be very easy to remember the structure of drug. Okay. So most of the peoples are not answering those questions. It means that they are not present in the lectures, because there are 69 students are present in this lecture and only few people are giving the answers. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 students has given the answer. Yes, hydroxyethyl is added at the first position and methyl is added at second position. Very good. Okay. So this is very important step to remember the structure. So this is nitroimidazole structure. If you observe the structure of this, you will find out some group is attached at two positions and some group is attached at one number position. So this is the methyl group at two number positions, and this is hydroxyethyl, or you can say that the ethanol. So ethanol is at one number position. Ethanol is at one number position, and methyl group is at two number position. So this is the difference. So it's very easy to remember the structure, isn't it? So methyl group at two number positions and ethanol group at one number positions, and your structure will looks like this. Okay. Then we will discuss the IUPAC name. So structure will looks like this. So methyl group at two number positions and ethanol at one number position. Okay. So if you observe the structure, this is the ethanol. So you have to write down this is as ethanol or ethane 1-ol. And then rest of the things are considered as substituents, because on imidazole there is no other functional group is present. Already we have discussed the nomenclature system of the nitro compound. That time we have come to know that nitro group is always considered as substituent. So this is considered as substituents. Okay. Methyl is also substituents. So this is the alcohol. One number is given here, two number is given here. So 1, 2. So again numbering start from the one number, because here your ring is started. So this is the numbering of ring 1, 2, 3, 4, 5. So on ethanol, two number positions. Okay. This is the ethanol, and two number position there is substituent. So this two. Okay. What is substituents? Imidazole substituents. Imidazole also having the substituents. So what is substituents? 2-methyl. So this is the 2-methyl. Okay. 5-nitro. So this is the 5-nitro. 1H imidazole. So we have replaced E with YL, because it is substituents. It is not a proper ring. It is a substituents. That's why we make it as YL. Okay. Imidazole 1-il. 1 means what? The imidazole ring is attached to ethanol at one number position. लक्षात घ्या विद्यार्थी मित्रांनो, इथेनॉलच्या 2 नंबरच्या कार्बन ॲटमवर इमिडाझोल अटॅच झालेली आहे. बरोबर. पण इमिडाझोल रिंग इथेनॉलला कुठे अटॅच झाली? त्याच्या 1 नंबर पोझिशनला. त्याच्या 1 नंबर पोझिशनला अटॅच झाली. म्हणून आपण लिहिताना काय लिहितो? इमिडाझोल 1-il. Imidazole 1-il. This one indicates the position of imidazole ring at which the ethanol is attached, and this 2, see here, this 2 is the position of carbon atom on which the imidazole ring is attached. Okay. Because it does not contain the multiple bonds. That 1H is always be there because it does not contain multiple bonds. Once it is a multiple bond, means carbon nitrogen double bond, that time only you don't consider as this H, because this name is generated through the IUPAC nomenclature software. So this software also gives the 1H name, because it indicates that why this 1H it indicates. If suppose we have not given number 1 here, so they have started numbering from here also. Okay, and that time the numbers are very less possible number. See here, 1, 2, 3 and 4. So 1, 2, 3 and 4 number is the lowest possible number. Okay, that's why we take the 1H, because if you see the structure of imidazole, it looks like this. And where we have attached, at 1 number position we have attached. If suppose you have not taken this 1H, then you will not able to observe or you will not able to give the correct numbering, where actual the substitution is taken place, whether at 3 number position or 1 number position. So to make it clear, whatever the groups is attached, it is attached at 1 number position. Okay. Once you have not written this 1H, your numbering can start from this nitrogen also. Okay, 1, 2, 3, 4, because it gives the lowest possible number to the heteroatom as well as lowest possible number to the your substituents also. If you numbering like that, that is 1, 2, 3, and 4. So lowest possible number is taken place. But what happens if you attach at 1 number position? Your numbers remains as it is, even though the 5 number carbon atom means last carbon atoms also having the substituents. That's why you must take the 1H positions. It means that the whatever the attachment is taken place, this is at 1 number positions. And for that extra hydrogen, if it is containing double bond, then only you have to remove this H. Then only you have to remove it. Otherwise, it will remains as it is, because it is present in parent structure. तो पॅरेंट स्ट्रक्चर मध्ये 1H असल्यामुळे तो तासाच्या तासा पुढे तो कॅरी होईल. जरी त्याच्याकडे हायड्रोजन नसला तर ते इंडिकेट करतंय की त्या ठिकाणी हायड्रोजन होता म्हणूनच अटॅचमेंट झाली. लक्षात घ्या. बिकॉज इट कंटेनिंग दिस हायड्रोजन, देन ओनली दिस अटॅचमेंट टेकन प्लेस. So don't stuck through the exact rules. Okay. So to avoid the confusion between numbering, wherever their parent is containing that type of the rings, that type of hydrogen, you have to be very careful while writing its the name. Okay. I think this is sufficient for explanation for 1H positions. If you still want any explanations, we will discuss it after completion of this lecture. Now, you are able to remember the structure of imidazole, then nitroimidazole, and then through nitroimidazole, we have come to the structure of metronidazole. And then you will find out the methyl group at 2 number positions and ethanol group at 1 number positions. But how to remember that? I will give you one very simple tricks to remember the structure of metronidazole. Okay, so how to remember the structure of metronidazole? So dear students, here I am giving one smart tricks for you peoples to remember these structures in very short period of time. In last lecture, I also told you that you have to apply this logic, these smart tricks immediately on that day to remember the structure of that drugs. Okay. So metronidazole is a imidazole derivative, but it is not actual imidazole derivative. It is a nitroimidazole derivative. It is a nitroimidazole derivative having methyl group and ethanol groups. So this information is sufficient to remember the structure or to draw the structure of metronidazole. Okay, so metronidazole is a nitroimidazole derivative and it containing methyl group as well as it containing ethanol groups. But how to remember it? So let's discuss. Okay, so I have break this word metronidazole. So just observe on your screen. I'm going to break the word metronidazole itself. See here, I have break it. Again, observe it. M plus E plus tronidazole. Okay. So this is metronidazole. First letter is M, second letter is E, and latter is tronidazole. Okay. So what I have did, I have just break down the letters in the name of metronidazole. So M plus E plus tronidazole, it will becomes metronidazole. So this tronidazole is represent as 5-nitroimidazole. Okay, so last word is what? Tronidazole. So we have to go from left to right now. Okay, so first is what? Tronidazole. So it is last. So nitro group is at last number carbon atom. So this is the nitroimidazole structure. Okay, so this tronidazole stands for nitroimidazole. Now up to that point your structure is covered. So this is your structure. Now what is remaining? E is remaining. So E, we have separated the E. Okay, E we have separated, and E stands for the ethanol, and ethanol is present at first positions. Okay, ethanol is present at first position, so you have to attach the ethanol at first position like this. Okay, ethanol is at first position, correct? So E stands for ethanol, and it should be at first position. It should be at first position. So now we have covered up to this part. Now what's remaining? M. M stands for methyl. M stands for methyl, and methyl is at second position. Methyl is at second position. So attach the methyl group here. Already here is attached. Okay. So once again, I will repeat the things for you peoples. So metronidazole word itself, you have to break down it in these fashions. So M plus E plus tronidazole. Tronidazole is nothing but the nitroimidazole. Tronidazole is nothing but the nitroimidazole. So this is the structure of 5-nitroimidazole. Then E. E stands for ethanol. Ethanol is at first positions. Then observe here at the left bottom corner, ethanol is attached at 1 number position. Okay, great. Now what is remaining? M is remaining. So M stands for methyl, and methyl is at 2 number position. So here automatically your methyl group is present. See here, methyl is attached here. So this is the smart way to study or to remember the structures. In these fashions, you have to make some logics, make some tricks to remember the structure. So I think this is a very easy to remember the structure of metronidazole. I have done it when I was in B Farm, that is third year B Farm. That time I have make this logic to remember the structure of this metronidazole. Discuss about the dapsone, furosemides, and all other things. Try to catch all these logics for the remembering the structures, because it is very important to draw the structures. If you want more marks or score the in pharmaceutical chemistry too, you have to write the IUPAC name, as well as you have to draw the correct structure. If you draw the correct structure and it is followed by the IUPAC name, definitely you will get more marks in the chemistry, and no doubt you will be score very high in these chemistry subjects. 2 years before, one of the students from our department got 76 marks out of 80. How many? 76 marks out of 80, and in sectional exam she got 20 out of 20. So out of 100 she scored 96 marks. So this is the very easy subjects to score maximum marks and to get the admission to direct second year B Farm in a government and well reputed college. So if you want to do a B Farm in a good college, then you have to score a maximum in each subject. So for chemistry, I will take care of that. You have to just assure me that, sir, I want to do a B Farm, and I will start the study as per your suggestion. Then I will start the give the suggestions to the students. Okay, but you need to follow my tips and tricks. Then only you can able to get more and more marks in chemistry also. Okay, so this is how you can able to draw the structure of drugs. So let's see the property. So here I have mentioned you one popular brand name of this metronidazole, and popular brand name is Flagyl. Okay, so popular brand name of metronidazole is Flagyl, and dose is 500 mg. So this is the tablet. So tablet form is also available. Sometimes creams is also available to treatment of the vaginal infections also. Okay, so metronidazole is occurs as a white crystalline or creamy white powder. It does not have any odor. It is having very bitter taste. It is soluble in alcohol, and it is effective in orally as well as topically. Means locally also it can be used, but most probably it is taken as orally in case of diarrhea, or if there is some other infections, that time it can be used topically. So it is available in white powder. It is odorless. It has a bitter taste. It has a bitter taste. It is slightly soluble in alcohol, which is effective in orally as well as topically. So, so mechanism of action of these drugs. If you see here, it will inhibits the nucleic acid synthesis in parasites. It will inhibit the nucleic acid synthesis, that is DNA and RNA, deoxyribose nucleic acid and ribose nucleic acid. So these drugs affect on the nucleic acid synthesis pathway. So nucleic acid synthesis get blocked. So DNA will not form. Once the DNA will not form, so from DNA, RNA will not form. From RNA, the protein will not form. So if there is no protein, deflection of protein, DNA and RNA, ultimately due to the deflection of these nucleic acid as well as protein, that particular parasites are get killed. So by this way, this metronidazole is act by inhibition of nucleic acid synthesis. Okay. So sometimes the cream is used. So here I have taken one photo of metronidazole cream. Okay. This cream basically useful to treatment of bacterial vaginosis. So bacterial infection of vagina, as well as this cream is useful in the treatment of trichomoniasis. So it is the infection of one of the parasites, that is trichomes. So that trichomoniasis and bacterial vaginosis, this metronidazole is useful in the treatment of these drugs. Basically, it is useful in the treatment of amoebic dysentery or amoebiasis. Sometimes it is also called as anti-protozoal agent. So for the treatment of protozoal infection also, this metronidazole is used. Okay, so